Good morning to all. In today's class, we will discuss literals and polymorphism concepts. Okay. In Unit 2, we have the concepts like identifiers, keywords, data types, variables, literals, operators, control structures, typecasting, classes and objects. After that, we have constructors, then polymorphism, then last inheritance. Okay, these are the topics we have in Unit 2. So here already I completed identifiers, keywords, data types, variables and classes and objects. These and constructors also I have completed. Okay. Now in today's class, first I will explain literals. After that I will explain polymorphism. So already explain identifiers. You know what is an identifier and what are the rules for writing identifiers. Next keywords. Next data types. There are two types of data types, primitive data types and non-primitive data types. Next variables are also of two types, primitive variables and reference variables. Next we will see literals. So for understanding this literals concept, we need to know data types and variables. So without understanding the concepts of data types and variables, it is not possible to understand literals. That's why data types, variables, literals, these three concepts are very, very important. If you take any Java program, these three concepts are very, very important. Okay. Now, we will start literals first. After that, I will explain polymorphism. Literal means a value which is assigned to a variable is called literal. Simply it is a variable, not variable, it is a value which is assigned to a variable. So here I will explain what is a literal. Then after that, what are the different types of literals. So literals are constants. Literal means a value which is assigned to a variable is called literal. So here if you take this statement, that is int a is equal to 10. So in this statement, so how to understand this statement is, this int is called data type and a is a variable and this 10 is a value. Okay. So here int is a primitive data type and a is a primitive variable, because this is a variable which is defined with primitive data type. That's why a is called primitive variable. And if you take the value 10, it is called literal. Means it is a value which is assigned to a variable. That's why it is called a literal. Next, coming to this statement, string S1 is equal to Ramu. Here Ramu is called literal. Why? Because it is a value which is assigned to this variable S1. That's why it is called literal, and it is also called string literal. So here in this statement we can say string is a non-primitive data type, then S1 is a reference variable, because S1 is a variable which is declared with string data type and string is a non-primitive data type. That's why S1 is called reference variable, and this right hand side is called literal or constant. Okay. So if you take this statement, student S1 is equal to new student. Here right hand side is called object. That's why it is not a literal. If you take this statement also, string S1 is equal to new string of Ramu. So it is, see if you take the right hand side, it is creating string object. That's why it is not a literal. Okay. So whenever we use new operator, so in this case, it is creating an object for string class. That's why it is not a literal. So in these two statements, means int a is equal to 10 and string S1 is equal to Ramu. So in this statement, it is called integral literal, and in this statement, it is called string literal. Okay. So to understand literal, data type is important and variable also important. That's why in this statement, we have data type, variable and value. This value is nothing but literal, and this value is assigned to this variable. Okay. Now coming to the types of literals, here we have 5 different types of literals. They are integral literals, floating point literals, character literals, Boolean literals, and string literals. So these 4 types of literals are with respect to primitive data types. This is with respect to non-primitive data type. You know there are 8 primitive data types, no? So with respect to primitive data types, we can categorize the literals in 4 ways. Integral literals, floating point literals, character literals, and Boolean literals. So we will see one by one. First we will see integral literals. So you know there are 4 integral data types now in primitive data types. What are the 4 primitive data types with respect to integers? Byte, short, int, long. These are the 4 integral primitive data types. So we will explain integral literals with these 4 integral data types. So next concept is, if you take this statement int a is equal to 10, this is called integral literal. And if you see here, this is a value that is 10, means which is in the decimal notation. So like that, here I can take this integral literal in 3 notations. They are decimal notation, octal notation, and hexadecimal notation. So integral literals can be taken as in 3 notations. They are decimal notation, octal notation, and hexadecimal notation. What is decimal notation? You know, it is 10. It means here we can take the digits from 0 to 9. Next, if you take octal notation, it is 8. Means we can take the digits from 0 to 7. And how do we know whether it is in the form of octal notation or not? Is if by seeing the prefix. So all the octal numbers should be prefixed with 0. Okay. Next, coming to the hexadecimal notation, here the number is 6. And the digits are from 0 to 9, and 10, 11, 12, 13, 14, 15 are denoted with A to F. So capital A is for 10. Like that, capital F is for 15. So 16 means 0 to 15. Okay. Now here for hexadecimal notation, the prefix is, it can be either 0 small x or 0 capital X. Okay, any number, if it is prefixed with 0 small x or 0 capital X, means it is a hexadecimal number. Like that, integral literals can be expressed in any one of these 3 notations: decimal notation, octal notation, and hexadecimal notation. Now we will see one program on, we will write one program on integral literals. Now if you take this program, class name, so class test, inside that I have written the main method, that is public static void main string args. Next, inside the main method, I am taking integral literals. So already explained, no? To write the integral literals, we can use 4 data types. They are byte, short, int, and long. So here what I will take is, I will take the data type as byte, int, long in these 3 statements. These are integral data types. Okay. Next, byte b is equal to 10. Here in integral, here in this representation, I am using 3 notations. That is decimal notation, octal notation, and hexadecimal notation. So already you know decimal notation means it is simply a number which takes the digits from 0 to 9, and it should not be prefixed with anything, either 0 or 0x. That's why this is called decimal notation, which is an integral literal. Next, if you take this statement 0, 1, 0, 10. 0, 10 means this 10 is prefixed with 0. That's why we can understand, or the compiler can understand that it is an octal number. Okay. Next, if you take this one 0x10, means here the compiler can understand this is hexadecimal number. Why? Because this 10 is prefixed with 0x. Okay, so like that here I have taken 3 data types, integral data types, and here I have taken the integral literal in 3 notations, that is decimal notation, octal notation, and hexadecimal notation. Okay, when you print these 3 variables, okay, what will be the output? So the output is decimal notation. If you take the decimal value, that is 10, it is internally converted into binary number, and that binary equivalent of 10 is stored in the memory, because compiler knows only zeros and ones. The value 10 will not be stored as it is in the memory. The binary equivalent of 10 is stored in the memory. After that, when you print the variable, that is b, you will get 10 only. Again, that binary equivalent of 10 is converted into decimal, and the value 10 is printed as output for this statement. Next, when you print the value of a, here it is in octal notation, no? So here how next first this octal value is converted into decimal, that is integer. So how it will be converted is, it is using 8 power 0, this is 8 power 1. Octal means 8, no? So first take from right to left, 8 power 0, 8 power 1, and take the sum of the products. That is 8 power 0 into 0 is 0, 8 power 1 into 1 is 1. So 8 plus 0, 8 plus 0 is 8. So the output is 8. Next, coming to the hexadecimal notation, again first it will be converted into decimal value, that is integer value. Again how it will be converted is by taking 16. First 16 power 0 into 0 plus 16 power 1 into 1. That is 16 power 16 plus 0, which is 16. That is the integer value corresponding to this notation. Again that 16 will be converted into binary form. Then the binary equivalent of 16 is stored in the memory. That's why when you print this L1, then you will get 16 as output. So the output for these 3 statements is 10, 6 and 10, 8 and 16. Okay. So this is the program on integral literals. Here we can take any one of the 4 data types, that is byte, short, int and long in place of data type. Next, when you take the integral literal, you can write or you can take any one of these 3 notations. That integral literal can be decimal notation or in octal notation or in hexadecimal notation. So this is the simple program on integral literals. Next, coming to the floating point literals. Here you know floating point data types, there are 2, no? They are float and double. So with respect to, by taking these 2 data types, I can explain the concept floating point literal. Now I will write a program using floating point literals. Same class test, and they take the main method syntax as it is. Then inside the main method, I will declare the statements like this. So float f1 is equal to 2.3f. So what is the meaning of this statement? This is data type, this is variable, this is value. Okay. So this value is called literal. And which type of literal it is? It is called floating point literal, because this literal is assigned to a variable f1 which is of floating point data type. That's why it is called floating point literal. In the same way, I can take the data type as double. Double d1 is equal to 10.3d. Here this suffix f is first for floating point literals. Otherwise, you will get error. Already explained what the reason behind this one. Next, double d1 is equal to 10.3d means here this is called floating point literal, and here d is optional. Okay. Next, when you print these values, that is these variables f1 and d1, you will get 2.3 and 10.3. So this is the example program for floating point literals. Here I can take any one of the 2 data types, that is float or double, and here these are the floating point literals. Okay, so when you execute this program, you will get the output as 2.3 and 10.3. Next, coming to the character literals. Now we will write one program using character literals. Here already explained, in Java the character will take 2 bytes of memory. But whereas in C language, it takes only 1 byte of memory. That is the difference between character in C language and character in Java language. Because using the Java program, we can develop web applications. That's why it has to support all the international languages. Okay, so character in C language takes only 1 byte, means it is taking ASCII code. Here, character in Java, it uses Unicode. Unicode means, okay, here it is using Unicode. So the range for character in Java is, you know, a character is unsigned, no? That's why 0 to 65535. Okay, this is the range. Okay, next, if you take hexadecimal notation, already explained. So it is single quotes \u 4xs, means to write the value, that is from 0 to 65535, you have to use 4 digits. Okay, 4 digits, nothing but here 4xs. So here I will explain. Now same program, class test, public static void main string args. Inside this char C1 is equal to single quote A. Single quote A, quote A means here internally this A is not stored as it is in the memory. Okay, the ASCII value of A is stored in the memory. Okay, what is the ASCII value of small a is 97 and the ASCII value of capital A is 65. So first it will take the ASCII value of A, that is 97. After that 97 is converted into binary form. Then that binary equivalent of 97 is stored in the memory. Okay, but if you print this variable C1, you will get the value as A. Why? Because this variable is declared with char data type. That's why even though the value is stored in the form of binary, that is binary equivalent of 97, but when you print this variable value C1, you will get A only. Like that, if you take the second statement, char C2 is equal to 97. It is an integer value, no? So internally, the integer is converted into binary form and stored in the memory. Next, it is what is the corresponding character for this 97 is small a only. The ASCII value for capital A is 65 and the ASCII value for small a is 97. Because it is declared with char data type, so if you give integer also, if you print the value, you will get A only. Because you know the ASCII value for small a is 97. You can give integers also here. Next, if you take the third statement, you know it is the hexadecimal notation. Why? Because this value is put in the single quotes. So within the single quotes, if you have \u 4 digits, then it is the hexadecimal notation. Okay. So in the hexadecimal notation, in place of these 4 x's, we can use 4 digits, and the digits are also from 0 to 9 and capital A to capital F, or small a to small f also correct. So what is the decimal equivalent of this hexadecimal? So you know hexadecimal notation means we have to use 16. That's why 16 power 0 into 1 plus 16 power 1 into 6 means 64 plus 1, which is 65. So the integer value for this one is 65. What is the not 65? 97. What is the value? 97 only. Okay. So here it is 16 power 0 into 1 plus 16 power 2 into this one. That's why it is 16 power 0 into 1 plus 16 power 1 into 6. 16 power 1 into 6 is 96 plus this is 1. So total it is 97. So here the integer value corresponding to this hexadecimal notation is 97. What is the ASCII value, or what is the equivalent character for this ASCII value is again small a. That's why if you print the variables C1, C2 and C3, you will get only small a. This character is the output for all these 3 notations. So in character also we can use 3 notations. Directly we can put the character in single quotes, or we can use the ASCII code, okay, or you can use the hexadecimal notation, that is for Unicode. Okay, like that we can express the character literals in 3 ways. So this is the program on character literals. Now coming to the Boolean literals. Already you know Boolean data type. So Boolean data type, in Boolean data type it will take only 2 literals, they are true and false. Okay, it will take only 2 values. And now I will write the program on Boolean literals. Class test public static void main string args. Inside this I have taken Boolean b is equal to true. What is this true? It is called Boolean literal, because it is a value which is assigned to this variable b, and which b is of Boolean data type. That's why I can call this literal as Boolean literal. If you take Boolean a is equal to false, then this false is also called Boolean literal. Okay. Now we will print these 2 variables, that is b space a. You will get the output as true, then space followed by false. That is the output for this program. This is the simple program to understand the Boolean literals. These true and false are called Boolean literals. Next, up to this we have discussed, okay, literals with respect to primitive data types. So we have completed integral literals, floating point literals, character literals, and Boolean literals. So these 4 types of literals are with respect to primitive data types. Next, coming to non-primitive data types, here there is only one type of literal, that is string literal. Only by taking this string class we can discuss string literals. We can't, there is no concept of student literals, or for any other class or interface we can't write literals. Only for the predefined class string we can write literals. That's why in non-primitive data types we have only string literals. And now we will see one program on string literals. Okay. So string is a non-primitive data type because it is a predefined class. Now, okay, we will see this program. Now here string S1 is equal to Ramu. What is the meaning of this statement is, here it is called string literal because double quotes sequence of characters means it is a string. Okay, this string is assigned to this variable S1, and this variable is declared with non-primitive data type, that is string. That's why it is called string literal. Similarly, in this statement I have assigned this literal to this S2. That's why when you print S1 and S2, you will get the output as Ramu and Krishna. You see here, the output for S1 is Ramu and the output for S2 is Krishna. So with this, literals concept is completed. So there are 5 types of literals. There are integral literals, floating point literals, then character literals, Boolean literals, and then finally string literals. So in the final exam, if the question is explain the literals with example, means first explain what is a literal, and after that what are the different types of literals, and try to write one small program on each type of literal. Okay. Next, so with this literals completed. So coming to the next concept, that is polymorphism. So polymorphism is very, very important in Java. Okay. So what is poly? What is morphism? Poly means many, morphism means structures. So many structures. Now we will see polymorphism concept. Now coming to polymorphism, here again in polymorphism we have 2 types of polymorphism. They are compile time polymorphism and runtime polymorphism. Okay. So what is compile time polymorphism? So if the polymorphism occurs during the compilation time, then it is called compile time polymorphism. Next, what is runtime polymorphism? If the polymorphism occurs during runtime, then it is called runtime polymorphism. So the example for compile time polymorphism is overloading, and overriding is the example for runtime polymorphism. See, this overriding concept is there in inheritance. Okay, when we study inheritance, at that time we will see overriding. Now here we will see now overloading. Okay, so overloading means it is compile time polymorphism. Okay, now what is overloading and how many types of overloading I will explain here. So here in overloading, again we will discuss two types. First one is constructor overloading and the second one is method overloading. Okay, if you take this overriding, it is method overriding. Here only one type in case of overriding. But in case of overloading, we have two types. They are constructor overloading and method overloading. So this polymorphism is very, very important concept in Java. Here the questions are like this. Explain compile time polymorphism with example, or explain runtime polymorphism with example. Example means you have to write one program on that concept. Next, third question is explain constructor overloading with example. Next, explain method overloading with example. Next, explain method overriding with example. Or the question may be explain polymorphism in Java with example. So how do we explain polymorphism concept in Java is, okay, so in polymorphism we have two types. They are compile time polymorphism and runtime polymorphism. Next, overloading is the example for compile time polymorphism and overriding is the example for runtime polymorphism. Again in overloading there are two concepts, constructor overloading and method overloading. So now I will explain constructor overloading. Next, in the next class we will see method overloading. These two programs are very, very important. Okay, so explain about compile time polymorphism means, so what is compile time polymorphism? Explain, that is, if the polymorphism occurs during the compile time, then that polymorphism is called compile time polymorphism. Again, there are overloading is an example for compile time polymorphism. Again, in overloading we have two types, constructor overloading and method overloading. Write one program on each of these two types. Okay, if the question is compile time polymorphism means you have to write two programs, that is one program on constructor overloading and one program on method overloading. If the question is runtime polymorphism means write one program on method overriding. Okay, we will discuss this method overriding concept when we discuss inheritance concept. Okay, and now first I will explain constructor overloading. After that I will explain method overloading. So these concepts are very, very important in Java. So what is constructor overloading? Already explained constructors concept in depth in the last classes. Okay, and now coming to constructor overloading. What is constructor overloading? Two or more constructors having the same name and they differ either in the number of arguments or type of arguments or order of arguments. Then in this case, the constructors are said to be overloaded constructors. Okay, so again I will repeat, we have to take two or more constructors. Means to explain the concept constructor overloading, minimum number of constructors should be two. With one constructor we can't explain constructor overloading. So minimum number of constructors must be two. So two or more constructors having the same name and they may differ either in the number of arguments or type of arguments or order of arguments. Okay, you have to remember this. Now next I will show you the examples on constructor overloading. So in this example, so the class name is student. So class student, inside the class I am writing the constructors. Already you know the constructor concept. The constructor name and class name must be same and the constructors should not have return type. Okay, and with or without parameters, both are correct. Now I will explain, we will see these two constructors. Okay, so inside class student I have written two constructors. First one is nor constructor and second one is parameterized constructor. So this constructor is having one parameter. Okay, now it is not constructor, it is parameterized constructor. If you to see these two constructors are having the same name. So two or more constructors having the same name, and they may differ either in the number of arguments or type of arguments or order of arguments. If you see the number of arguments in these two constructors, here 0 arguments, here 1 argument. Means these two constructors are differing by number of arguments. Here 0, here 1. That's why these two constructors are said to be overloaded constructors. Okay, this is one example on constructor overloading. We will see one more example on constructor overloading. If you see, you can identify whether it is a constructor or method. If you see this syntax, you can understand that it is a constructor. Why? Because the constructor name and class name must be same and no return type. And it can have parameters. Okay. And now this is one constructor in this class and this is another constructor. So this class consists of two constructors. And we will check whether these two constructors are overloaded or not. How do we check is, now we will see the parameters. Here this first constructor is taking 2 parameters and the second constructor is also taking 2 parameters. Now then, how do we say these two constructors are overloaded constructors is, if both the constructors are having the same number of parameters, then see the type of parameters or order of parameters. If you see the type of parameter, type and order, here it is taking int and float. But if you see this one, here it is taking float and string. Means they are differing on the type of parameters, even though both the constructors are taking 2 parameters. But they are differing on the type of the parameters. Here if you see int float, here if you see float string. So in this case, we can say these two constructors are said to be overloaded constructors. Okay. Now these are the best examples for explaining constructor overloading. Now we will see the program on constructor overloading. So explain constructor overloading with example means first you have to explain the definition. After that you give 2-3 examples to understand constructor overloading. After that write the program. Now I will explain the program. So here we have class student. So inside the class I have taken the instance variables. Okay. So here roll number, marks and name are instance variables. Why? Because these 3 variables are declared inside the class and outside the method or constructor or block. That's why I can say roll number, marks and name are instance variables based on the position. After that, these 3 variables are not declared with static keyword. That's why I can say roll number, marks and name are instance variables. Only instance variables are stored inside each object of student. Okay, student class. Now these 3 are instance variables. After that, now I will start writing constructors. So minimum 2 constructors are must to explain the concept of constructor overloading. But inside this student class, I have written 3 constructors. What are they? I will explain. Now the first constructor is user-defined no-arg constructor. Already explained about user-defined no-arg constructor. So here student means constructor name and class name must be same. Next it is not taking any parameters. That's why this constructor is called user-defined no-arg constructor. Why it is user-defined means the programmer is writing this constructor inside this class. That's why it is user-defined no-arg. This constructor is not taking any arguments. That's why this constructor is called user-defined no-arg constructor. You know the types of constructors. It is one type of constructor. Okay. Now inside this constructor, what I am doing is the main purpose of constructor is to initialize the instance variables of that class. Okay. So what are the instance variables for this class? Roll number, marks and name are the instance variables. Okay, so these variables must be initialized inside this constructor. So the main purpose of constructor is to initialize the instance variables of that class. Okay, so I am initializing the instance variables roll number, marks and name inside this constructor with the values 1, 95.6 and Arjun. Name is a reference variable, no? So, and it is of string data type, that's why double quotes sequence of characters means it is a string. This string is assigned to name. Okay, so it is a user defined NOR constructor. This is the first constructor I have written inside student class. What is the next constructor? So this is the second constructor for this class. It is user defined parameterized constructor. Already we know how to write the parameterized constructor. Okay, so how do we write the parameterized constructor in this class is, again take the same class name student, and here how many parameters should we take? Okay, depends on the number of instance variables. Here how many instance variables are there? 3. That's why we need to take 3 parameters. Okay, for this constructor. So here what are the 3 parameters? Roll number, marks and name. So if you take the parameter names and instance variable names same, then in that case we have to use this keyword. Already I explained this also, but the data types must also be same. So what are the data types of the instance variables? Int, float and string. So for the parameters of this constructor, you have to take the same data types, that is int, float and string. Okay, after that when we use the same names, that is if the parameters names and instance variable names are same, then we have to use this, that is this dot roll number is equal to roll number, means this refers to the current class object. I will explain later. So how do we write the, here is this dot roll number is roll number, this roll number is this, and this dot marks is equal to marks, this dot name is equal to name. So this is the parameterized constructor, which is second constructor for this class. So till now we have written 2 constructor. One is user defined NOR constructor, and another one is user defined parameterized constructor. Now I want to write one more constructor also, because as per the definition of constructor overloading, 2 or more constructors having the same name. That's why I want to write one more constructor, that is third constructor for the same class. Now here this is the third constructor. This is also a user defined parameterized constructor, because this constructor is taking 1 parameter. This constructor is taking 3 parameters. Okay, but the difference between the second constructor and third constructor is, here it is taking 3 parameters, here it is taking 1 parameter. That's why both these 2 constructors are called user defined parameterized constructors. But here this constructor is very, very important. The previous 2 constructors already explained in the previous programs. So we have written one program on user defined NOR constructor and one program on user defined parameterized constructor. No? Now what is the difference between the previous problems and this program is, in the previous programs we have written only one constructor, but in this program we are writing more than one constructor. So if you take this example program, in this program I am writing 3 constructors, that is user defined NOR constructor, next user defined parameterized constructor and user defined parameterized constructor. But how can we say these 2 constructors are overloaded constructors? Because here this constructor is taking 3 parameters, here it is taking 1 parameter. The concept of constructor overloading is 2 or more constructors having the same name, but they may differ either in the number of arguments or type of arguments or order of arguments. If you see here it is taking 3 parameters, it is taking 1 parameter. Means here these 2 constructors are differed by the number of arguments or parameters. That's why we can say these 2 constructors are said to be overloaded constructors. But here in this class I am writing 3 constructors. All these 3 constructors are said to be overloaded constructors. You can write any number of constructors, but minimum number of constructors must be 2. Now I will explain the third constructor. Here it is very important. Please try to understand this constructor. Here for this constructor, I am giving the parameter as again student class reference variable I am giving. So I will explain this in while explaining the flow. Now remember, student class constructor is taking the parameter as student class object. Okay. So in Java, so for methods or constructors, we can take the parameters as objects. Okay, we can write the parameters. Okay, or we can use objects as parameters. Okay, that's why here inside student constructor I have taken the parameter as student class object. Okay, you remember this is U for U. So this type of syntax is not there in C language. Okay, because in C language objects we cannot create. No. Now here this constructor is taking object as parameter. Okay. Next after that inside this constructor what I am writing is obj.roll number is assigned to roll number and obj.marks is assigned to marks. Obj.name is assigned to name. I will explain this next when we execute this program. Okay. Now here up to this we have written 3 constructors. Okay. After that the continuation is next after writing the 3 constructors I am writing the display method. This display method is same as the previous programs. So using this display method I am displaying the values of roll number, marks and name of each and every student of that class. Okay. So this display method is same. Okay. So after that this is the closing brace of this student class. This is the opening brace. This is the closing brace of student class. So now how do we describe the student class is? So the student class consists of 2 parts, state part and behavior part. State part consists of 3 instance variables. They are roll number, marks and name. And the behavior part consists of 3 constructors and 1 method. They are student north, next user defined parameterized with 3 parameters and user defined parameterized with 1 parameter and 1 display method. So if somebody asks you how do we describe the student class, means you have to explain with respect to state part and behavior part. So constructors and methods come under behavior part. Okay. Next, this is class student. It consists of 3 instance variables, 3 constructors and 1 method. Okay. Next, after that we will write 1 more class for creating objects of this student class. How do we create? Why we need to create objects for student class is to access the members of the student class. We need to create objects. It is must. Otherwise, we can't access the members of this student class. So to access the members of the student class, after defining the student class, we need to create the objects for student class. So where do we create the objects for student classes? Inside the main method of the same class also we can create objects for student class, or inside the main method of another class also we can create objects for student class. Okay, that's why we are taking separate class, that is class demo. Inside the class demo I will take main method. Inside the main method I will create the objects for student class. So here how many objects are created for student classes? I have created 3 objects. Why 3 objects I am creating is to access or to invoke 3 constructors. I will create 3 objects. So first in this statement it will invoke the first constructor. In this statement it will invoke the second constructor. With this statement it will invoke the third constructor, because I have written overloaded constructors in my student class. That's why to invoke all the constructors, I have to create different objects. So to invoke the first constructor, I have written this statement. Next object is for invoking the second constructor. Next object is for invoking the third constructor. That's why I have created 3 objects for student class. Okay, next. After that, 3 objects are created in the memory now. So to display the details of the three objects, I will invoke display method of student class using S1, S2 and S3. Okay. Now coming to the flow, how do we execute this program, or how do we save this program is using demo.java. How do we compile this program is java c demo.java, and how do we execute this program is java demo. So when we compile this program with java c demo.java, the compiler will compile these two classes, and after compilation you will get two .class files. They are student.class and demo.class. Okay. Next, with respect to constructors, first the compiler will check whether student class contains any constructor or not. So here inside the student class we have written three constructors. So in this case the constructor will not provide a default constructor. When the constructor will provide default constructor is if the class does not contain any constructor, then only the compiler will add default constructor for this class. If the class contains at least one constructor, then in that case the compiler will not provide default constructor. You understand this point? It is very, very important point. Next, after that, when we execute the program with Java demo, then the JVM will execute the main method first. Okay. Always execution starts from the main method. Okay. And who will invoke the main method is, it is invoked by JVM, that is Java Virtual Machine, when you write Java demo. Okay. When you write the statement that is Java demo, JVM will come into picture and it will invoke the main method of demo class. So inside the main method, I have the first statement as student S1 is equal to new student. Already explained this statement. Whenever an object is created, compulsory one constructor must be executed, whether it is default constructor or user defined constructor. So if you take this one, okay, when the JVM will execute this statement, so first it will see this one. So from this it will go to student class. Here the name is student, no? That's why first JVM will go to the student class and it will verify for matching constructor. So what is the matching constructor for this is? So inside the student class, this is the matching constructor for this one. That's why it will execute this constructor. So after execution of this constructor, what will happen inside the memory is, okay, one object, new student means this right hand side is nothing but object of student class. So one object is created inside the memory with address 50 and the address is assigned to this variable S1. That's why S1 holds 50. S1 is called a reference variable which holds the address of this object. Okay. After that what values are assigned to these instance variables? And one more point to remember is, inside each object only instance variables will be stored. So for this student class, the instance variables are roll number, marks and name. That's why only the instance variables of that class are stored inside this object. They are roll number, marks and name. So here the values are assigned using this NOR constructor, because from this statement it will go to this matching constructor and these values are assigned to the instance variables of the first object S1. That's why if you see the values inside the first object, you will get 195.6 and Arjun. Means this constructor is executed. Next, if you see the second statement, here it is, again it is constructor, that is student. Here it is having 3 arguments. That's why again from this statement, the JVM will go to the student class and it searches for the matching constructor. So this is the matching constructor for this. Okay. Now what will happen here is 2 is assigned to roll number, 98.6 is assigned to marks and this name is assigned to this name. After that, here inside this constructor we have written this dot roll number. This means This refers to the current class object. Here we are in this is the statement which is executed now. That's why this is the current class object. Means which is S2. This is the current class object. So it will assign these values to these instance variables of this class. That's why here what are the values we are sending? 298.6 and this value, this name. That's why here roll number is assigned to and marks 98.6 and the name is a reference variable which holds the address of the string class object. That's why here the name is stored in double quotes and the address of the string object is assigned to this name. That's why name is a reference variable. Okay, this is the memory for this second statement or second object. Okay, next, this is important. Student S3 is equal to new student of S1. Means here we have already created S1. So what is S1? S1 holds the address 50. That's why here we are sending the address. Address of the object we are sending. That is address of the object is stored in S1, no, that is 50. So when the statement is getting executed by JVM, again it will go to the student class and it will verify and it will execute the matching constructor. So what is the matching constructor for this is this one. Because this S1 is declared with student type and here OBJ is also declared with student type. That's why the matching constructor for this is this one. So from this it will go to this constructor and the code of this constructor will be executed. So here I will explain with memory this statement. So student S1 means, so 50 is, means S1 holds 50, no? So it is copied into this one, that is student OBJ is equal to S1. Already explained copying of an object. So here the statement becomes student OBJ is equal to S1. S1 holds 50, no? That's why OBJ also holds 50. Means OBJ and S1 both are pointing to the same object. Here she has not written OBJ. Write OBJ and inside OBJ put 50. Means OBJ and S1 are pointing to the same object, that is first object. So with OBJ I can access the members of this object. Now with OBJ, what is OBJ dot roll number? 1. OBJ dot marks 95.6. OBJ dot name Arjun. So I am assigning these three values to the reference variable, the instance variables of the third object. So how I will assign? So using OBJ, I am accessing the values of the first object. That's why OBJ dot roll number is, because OBJ is also pointing to this object. That's why OBJ dot roll number is 1 and OBJ dot marks is 95.6. OBJ dot name is this address, means Arjun. Next, now I am assigning these three values to the instance variables of the third object. Okay, that's why if you see the third object, so S3 points to this object and roll number is 1, means the values of the first object are copied into the third object. Because here the concept is student OBJ is equal to S1. Means we are copying the address of S1 into this OBJ. Means with OBJ we are accessing this object and with OBJ we are accessing the variables of this, and I am assigning these values to the instance variables of the third object. That's why roll number is assigned 1, marks are assigned 95.6 and name is this one. So like that third object is created with this third statement. After that 3 objects are created in the memory with values, no? After that what I will do is on the first object I will invoke display method. Means the display method will display the details of the first object. Again similarly on the second object I am invoking display method which will display the contents of the second object. Similarly on the third object also I am invoking the display method. It will display the contents of the third object. Okay. With this constructor overloading concept is completed. So inside one class we can write any number of constructors. It is the concept that is constructor overloading. Okay, next class we will see method overloading.